Okay, hi and welcome everybody to today's talk. No, it's not working anymore, Hendrik. Duh. Today's topic, System.out.Logger.
Yeah, welcome from my side too. I will do this talk together with Stefan and let's introduce ourselves. First, I'm Hendrik Ebbers. I live in Dortmund in Germany, and I'm one of the co-founders of the Karakun AG. And yeah, I'm working as a senior Java developer at the Karakun AG. And doing a lot in the Java community and Java ecosystem. Like I was already part of expert groups at JSRs. I'm a Java 1 rockstar and Java champion based on several sessions that I did on international conferences. And I'm one of the Adopt Open JDK members of the steering committee.
Yeah, I'll do the second part or the first part of the talk. My name is Stefan. I'm also a Karakun co-founder. I live in Switzerland, not in Germany. Karakun has multiple offices around the world. Not as famous as Hendrik, but I'll do my best to not fall off during the talk today. So today's topic is about logging. We'll start off with a little one-on-one about logging, looking into Java logging and libraries afterwards. The integration and architecture, this is more about if you have multiple libraries and things going on, then that will dive even deeper into centralizing logging if you have multiple applications or multiple logs coming from different places. And at the end, we'll have a short outlook to the future of logging. So let's dive in right away. So if you go to a dictionary and just ask what's a log, it first tells you it's a thick piece of wood. So this is not what we're interested in. We're more interested in the second part. It's a written record of things that happened. And historically seen, it comes from a logbook from a ship or a plane where you detailed write down what has happened during the journey. So why should we log in an application? Basically, it is to learn from the past. It's to retrace what has happened to our application, understand why certain events occurred. We can also gather information about how the software is used. So we may get some insight on how we want to improve the software in the future. So if we know what we want to get from the log, we also can deduct what we should log. So we should log the important events that happen in the application. Now, important is very vague, and I will not go more into details here because it is application dependent, what is important and what not. A good hint is log things that come from the outside of your software, outside of your module, some input that just you cannot know or not deduct from looking at the code. And also, it's very, very good to log unexpected behavior because that again gives you insight in what's working and what's not working in your software. Maybe more interesting is what you should not log. So you should not log too many details. And most of the time, it's not a good idea to log inside a loop, especially if it's a very fast loop, because it's just going to fill up your log files with a bunch of data that you're most likely not going to care at the end. And also, do not put sensitive data in your log because may not be the best thing, because usually logs are not as well protected as the database where your actual data is stored. So we have one example of a not so well written log here at the bottom. For example, we log out the birthday of the user max. The birthday is something that will not change, so it doesn't give you much information. You can always go to the profile of the user max and look at its birthday. You don't need to have this information in a log file. It's just redundant because it's nothing that's going to change. The user will always have the same birthday. And at the end, we'll see we're logging the password value, also not a good idea. And it looks like this log will just enter a line for every keystroke the user does. So it's not exactly a loop, but it's about the same thing. You're just logging too many informations. You can wait and log at the end when the user is finished filling in the field. So when we also look at logs, we often get a question, how long should we keep the logs? Short answer is forever. Long answer is keep it until you're really certain that you're not going to need it anymore. But since you can never be certain, just keep it forever. And nowadays, space is not that much of a problem. Maybe you have to think where to store them, not keep them too close to your application, but move them off to some archive. But then you're safe, keep them there. So has logging any downsides? Of course, nothing is for free. So you have to have an eye on performance. You can mess things up and lose a lot of performance logging. We'll go into that a little deeper in the middle of this talk. Also, what we sometimes see is that the code gets really cluttered. So we have a little example here. I'm not going to read it to you. It's just that there's more log lines here than there actually is code. And if you need to change this, it's just going to be a pain. So again, choose your logging wisely. So helping you writing good log messages is if you have a logging concept for your application. Because I myself find that when I had a bad day yesterday and I was debugging a whole bunch of things and I couldn't get it to work, the next day I'm just going to write more log statements because I was burned yesterday by having to search in the code and not having enough information in the log. On the other hand, this can happen the other way around, that when I find a cluttered piece of code where it's all the logs all over and I have to look into the log file and it's just going to scroll through tons and tons of log messages which do not give me any information. Maybe the next day I'm just going to be lazy and don't write any log files because who cares? There's already so much logging out there. So there's a good thing if you have a log concept for your application, for your project. And basically you want to write in there who is reading the log files. So who is monitoring the log files? So you know who to address when you write a log message. You also want to write in there what you want to extract from the log files. So you know which messages you should put in there. And also you don't want to write what you not want to extract. So you also know when not to log things. And finally, you may just define how logging is going to be different in production, test, or development environment. So this will help you choosing the right log level, because often I struggle when I write a message. Should this now be a debug? Should this be an info? Maybe just a trace? These are hard decisions that each one of us has to do in their everyday work. And having this logging concept where you can go back and say who I'm writing the log to, what information should it contain, and on which system should it be visible, then this helps me deciding when and where to write log messages. So this was all general about logging. This is independent of the language you're using. Today we want to dive a little into logging in Java particularly. And yeah, well, why should you use a logger? There's System.out. You can just like put everything on this console and you're fine. We can redirect the console to a file to keep it for later. That works. Well, I could now list a whole bunch of reasons why you should not use that. But I think the best is if I show you what a logging framework in Java nowadays just offers to you as free services that you just get when you use it. And hopefully you just get convinced by that. So the typical logging framework nowadays looks about like that. You have on the left side, you have your application code, all these gray files full of code. And then you have a hierarchy of loggers. So if you send a message to a leaf node, that message gets passed up all the way to the root. And at the root node, you get all messages that come from everywhere. Now you can attach to these loggers, you can attach something that's called appender. These are the blue boxes here. You can attach appenders at any level. So you can decide, I'm only interested in that subtree, or you can attach it at the root and say, hey, give me everything. You can also attach more than one appender to a logger. Maybe you want to have it in a file and also in a database. So you want to have two appenders and putting things at different places. The appender itself is kind of like the heart of the logging, because there you can put all your business logic. So you have these little symbols inside the appender. The first one stands for a filter, and the second one for a layout. We'll go into detail a little later. And at the very end, we're just going to write it to some storage. We don't care for now. So having a simplification of this basically is you start at your application, you pass some information to the logger is going to enrich it, pass it to the appender, it does its thing, and then finally you're just going to write it to the storage. And now we're going to go step by step through this process and see what's happening. The very beginning, when you're in your application, basically you tell the logger three things. This is a message, this is just a string. Sometimes you have an exception to pass along, sometimes not. And you also have the choice to use a marker. This is not used that often, but I think it's a really neat thing to do if you use markers. Marker is basically just a label or a tag you can attach to a message. So it's some additional information, a string, an additional string. You can say this is something, let's say it's something for an administrator to look at. So you can put a marker there and say admin, and then you can use that later in the process. The logger now itself is going to add a whole bunch of extra data. So it will add the logger name, the log level that you logged it on, timestamp, thread, and additional context. We'll look at the additional context just in a second. That's the cheap stuff the logger is going to add to it. The logger also can do more expensive things for you. So it can determine who called the logger, what class was it called from, what method was the call coming from, even what file and what line number it was coming from. Or it can create a stack trace, a small one, and say, okay, that was the last three methods that the log message came from. These are sometimes neat things to have, but keep in mind they're not cheap. What's also added by the logger is additional context. So this is context that comes from different places. First of all, the context of the logger. This is something you usually need when you have a application container, like a JBoss or so, where there are multiple applications running at the same time. So you'll have a central logging there, and the context of the logger kind of tells you which application it's coming from. If you have a standalone application or you just have a single application in your container, this is not that important. What's more interesting is you can, for each and every logger in this logger hierarchy, you can define properties and attributes at configuration time. And these properties and attributes, they're available to the logger, and they're also going to be added to your log message for further use. And finally, there's application context that you can also add. The most prominent here is the mapped diagnostic context, MDC. This is basically a thread local hash map where your application can put in key value pairs. And at the time the logger gets the message, it's just going to copy all these key value pairs that are in this thread local map and attach it to your log message. So you can, maybe if you get a request at the border, you have a servlet filter, you're just going to add the URL that was called and maybe some cookie that was inside the header. You're just going to put them in the MDC, and then somewhere deep down in your application, when you do a logging, these information is available, and you can, like, this way you can group all the messages that come from the same request because they all have the same cookie information in the MDC. Now, the second step in the logging process is going to be the appender. As I mentioned already, it has a filter where you can filter out messages that you're not interested in. Typically, this is by log level, but you can filter by any data that's available. Second, once the message passed the filter, it needs to be layouted in a way that we can store it. So these logging frameworks, they come with a whole variety of predefined layouts you can use. Typically, you have plain string or HTML. You can also have structured formats like JSON and XML, or even have standardized formats like GELF, which are used to exchange log messages across systems. These layouts can optionally also group messages into bulks. If like writing to a storage is expensive, you can group messages in a bulk and only write every 100 messages together as one write operation and save some time there. Finally, once the filter and the layout is done, all that's left over is writing to the storage. Here also the frameworks come with a whole variety of appenders that write to different storages. Simplest one is console. Also very common is file appenders, where you can write to any kind of file. There's often you find database appenders where you can write your log files directly into a database, or you have some remote appenders where you're actually going to send the data to a remote server where it's going to maybe further processed or just stored on your behalf. So let's have a little look at these logging frameworks that are nowadays rather common. This is a timescale from the past on the left to the future on the right. And we plotted the most recent release of the log framework that we could find. So you see Log4j version 1 was last published in 2012. So we can consider this as kind of dead. It's officially deprecated by the Apache Foundation. Also, Commons logging has been deprecated by the Apache Foundation. Just as a hint, we also plotted the Java versions on the bottom, so you kind of get a relation and see when things were last published compared to Java versions. If we start a new project, the ones on the right, those are the ones of interest. Maybe with a little caveat about the SLF4j. It looks like it's pretty new, but basically it's just an API. So you need to look at the most common logger that's used with SLF4j, which is Logback. So it kind of should have been closer to 2017 than it is to the border of 2020. Okay, as promised, we're just gonna look a little about performance, because that's often something you hear about logging. Logging can be expensive. For example, creating the message that you send to the logger can be expensive. You have string concatenation and other things going on there. So there are different things you can do to avoid unnecessary computation in case a log message does not get written to the log file. So you have some example on the bottom, like you can write an if statement around the log, just safeguard it like that. It's cumbersome, and I've seen that code. I used to write such code, but that was back in the times of 2000. Nowadays, most of the logging frameworks offer you something where you can pass parameters to the log message, and the parameters in the log message only going to get combined at the time when it's layouted. This is already really neat because it saves you a lot of computation in case the log message does not get written. But sometimes just computing the parameter you want to pass along already costs a lot of time. So since Java 8 we have lambdas, the newer frameworks offer you these nice supplier methods where you can, instead of passing a parameter, you can pass a supplier for a parameter, and the parameter is only going to be calculated in the case the event actually is going to be written to a log file. The other thing is, as I mentioned before, the logger itself adds data to the log message, and that can be expensive or cheap. So we have here an example log line, but do you really need the information about the class file and the class line? Because that's expensive to compute. The rest of the log line is just there. It's cheap and simple, but calculating the log file and the log line, this is going to cost you time in your application. And finally, when we write to the persistent storage, this also can cost time. I mean, writing to the console is really fast. Writing to a file, if it's on your same hard disk, it's fast. If it's already on a remote file system, it's going to be a little more expensive. If you write to a database, this is going to take some extra time. And if you send messages via HTTPS or SSL to some remote server, it's just going to take longer and longer. So there you can tweak your configuration, maybe win some time by bulk writing, or having a asynchronous writer. Means that you're going to keep a queue of messages to write to the storage and have a separate thread that's just going to visit that queue and write these messages out. So your main thread is not blocked by writing to the log storage.
Okay. Yeah, thanks for this introduction about logging and logging in Java, Stefan. So let's just take all this information and have a look how we can use it in our application and how we can integrate logging into Java applications and architecture that we use today. So let's start with the most easiest sample that we can think of, which is normally in Java a hello world. So what I did is I created a hello logger class. So this is just a simple Java class. And what this class does, instead of using System.out.println to print something on the command line, I will use the java.util.Logging, which is the standard logging framework or logging library that is already part of Java, of the OpenJDK, and therefore can easily be used in any Java application. When having a look at the source code, it looks like this. So what we are doing here, first of all, we create a logger by calling a static factory method, which is logger.getLogger, to create a logger with a given name. And then in our main method, we use this logger to create a log message, which in this here will be hello world. And by using the API with this .info method, we define that this message is defined in the logging level info. So that's everything what happens here, which means at the end we want to see our logging somehow. And to do so, what we can do is we can provide a configuration, which by default for the java.util.Logger is done by a properties file that is called logging.properties. You can pass this as an argument to the application when starting the application, the path to this file. And then this file is used to configure your logger. And maybe then you will print everything or write everything that is logged by the logger to an app-log.txt file. And then you can easily open that file and see all your logging information in this file. So this is a quite easy use case. And as you can see, so this is really just one additional line to a hello world that uses System.out.println, but we already have the benefit that we can create a file, in this case, the app-logs.txt, that contains all our log messages, or even filtered log messages, like in this case, only the messages that are in the level info or higher. That works quite good. But this was just an hello world, right? So let's have a look how this works in a more complex application. So in a real application, let's say like we want to create a server application. And what we normally have when creating such an application is that we have, that we have dependencies. So in this example, let's assume we have an application that has two dependencies. One dependency is to access the database. It could be something like Hibernate, but I want to make it generic here, so I do not work with concrete dependencies in this example. And we have another dependency that is a security library that maybe provides functionality for users to log into our application. Again, like we've learned before, what we can do now in our application, we can easily use the java.util.Logging and use it as before, define our loggers and use it to log out the information by providing the logging.properties file. And at the end, our log message will be in this app-log.txt. This is fine. This works perfectly. But there is a problem. And the problem comes with our dependencies. So maybe the database access library that we have on the left has some information too, where the developer of this library assumes that this can be interesting to log out. And maybe this library do not use the java.util.Logging to create such log messages, but use another logging library, like in this example, log4j. Maybe the security lib does more or less the same, but using another logger. So what we now have here is an application that internally depends on 3 different logging APIs and 3 different logging implementations. Log4j, the java.util.Logger, and TinyLog. And when just using the application like it is shown here, at the end in the app log.txt, we will see all the information that we log by using the java.util.Logging, but we won't see any information that is coming from the database access library or from the security library. And yeah, that is really a problem. So the big question is, how can we find, or where can we find this logging? And what can we do to get that logging? So first of all these libraries, I don't want to go now deep into how configure the different logging libraries, but in general, you can say that they are all configurable, some only by a config file, some provide an API for configuration too. But let's say we just use a config file. That would end in something like this for our application. So what we now have is we now have 3 different configurations. We have a configuration for the java.util.Logging, we have a configuration for log4j, and we have a configuration for TinyLog. And with the 3 configurations, we configure all 3 loggers and therefore at the end log into 3 different files. Everything that is coming from the database access is logged into this db log. Everything that is coming from the security lib is logged into this security log, and everything that is coming from our application code is logged into this app log. Yeah, maybe you already get the problem. This is not perfect, especially we currently have 2 dependencies here, right? And we do not want to continue this pattern and create for each and every maybe possible log framework a specific configuration and so on and so on. So this cannot be the solution, even if there are more problems than just providing several logging configurations. Because yeah, this just don't work and do not end in what we want to have at the end, which is a perfect log. Let's have a look at this log. This log contains the information of one user that does a workflow into our application. So first of all, the application starts. I assume this is coming from our log. Then the application connects to a database. Maybe that information is coming from the database library. And then later there's a user, Hendrik, that tries to log into the system. Maybe this information is coming from the security library, and so on and so on. And when having a look at how we defined it so far by having several log files, one for the database library, one for the security, and one for the application, we will split this log into several files. So we will have one file that is maybe the application log that just contains this line. And we will, for example, have another file that is the database log that is coming from the database library that contains this file. And by doing so, the workflow of the user Hendrik, like we've seen it in this combined log, cannot be reproduced based on the log anymore because it's separated in multiple files. And this is definitely not what we want. Before we have a look at the solution that you can use to do this, I will just give you some information about a stupid idea that people might have. That is like, okay, why not just configuring all the different loggers and logging frameworks so that they all write their log message into the same file? Yeah, I mean, you see it at the header. So doing this is really a stupid idea, because this will end in a lot of pain and problems. Just think about all these loggers might use different threads to write the information to the file. This could end in, splitted lines, so that you have in one line the information coming from two loggers. Maybe one of the logger provides a log or creates a log on the file. Another logger wants to log the file and it's not possible to log the file. Therefore, it cannot log. And these are just some ideas that you directly get when thinking about this idea. So this is definitely not the thing we want to use. And this shouldn't be done when having the problem that you have different logging libraries within your class path. So what is in general the problem, and what do we want to solve? So we have, as said, several loggers on the class path. And what we want at the end, we do not want to configure each of them. In general, we want to have one central configuration for our logging of our application. And we want to have one central output of our application where all the logging is combined. And we do not want to miss any logging that is coming from a dependency that is somewhere within our dependency graph of the application. So when sketching a solution, it might look like this. So we have our application with dependencies, and within our application and the dependencies, several logging frameworks or libraries are used. And all of them are collected. So the messages that are provided by those logging frameworks are collected. And then there's somehow a central appender or configuration that filters and mutates all these messages to save it within one single storage. So this is in general what we want to have. And the good thing is that there are solutions for exactly this. One solution that you can use is SLF4J, which is simple. SLF4J stands for Simple Logging Facade for Java. And this is a project that provides the needed functionalities that we need to solve this problem. In general, you can say that the SLF4J project provides three different core concepts or core functionalities. The first one is a logging facade, which is more or less a common logging API that is really just an API without a directly concrete implementation that you or libraries can use to just provide log information. Next to this, the project provides logging bridges and adapters that can be used to forward logging messages from external log frameworks, so from log frameworks that are used within your application, to the SLF4J API. So this is like all the logs are collected, and at the end, all the logs will go through the SLF4J common logging API. And the third thing is a logging binding that is an implementation at the end of the API based on a concrete logging framework like Log4j, like Logback, or something else. And this is then used to really use the appenders and store the logging somewhere. When having a look at an example, this might look like this. So let's say within our application and our dependencies, we use the comments logging and we use Log4j. And maybe we already migrated our application, or some of the dependencies have been migrated to directly use the SLF4J API. So what happens here is that first of all, we have the facade, so the API. This is the SLF4J API. This is defined by the SLF4J API jar. And this really just contains interfaces for a logger that you can use to log messages. And then we have adapters. Adapters are jars that adapt the functionality of a logging library or a logging API. Like in this example, we have two adapters, one for commons logging and one for log4j. And this means when talking about an adapter, so there are some kinds how an adapter works. But in theory, you can think about this, that the log4j over SLF4j jar, which is the SLF4j adapter for log4j, really is used instead of the log4j jar and really replaces this jar. So you remove the log4j jar out of your dependency tree and use this adapter that is coming from SLF4j. And what this adapter now does, it provides the exactly API of log4j. So this class really contains, for example, in org Apache log4j logger class that is normally part of log4j, with a specific implementation that forwards all the information to SLF4j and the public API of SLF4j. And by doing so, all the loggers that are used within our application or our dependencies at the end forward by RP calls all log messages directly to the SLF4j API. And this one now needs an underlying logging framework, so a binding to a logging framework. In this case, Logback is used, that implements the SLF4j API and forwards it to a specific logging framework like log4j. And now we can configure this Logback with, for example, Logback configuration file, something like this. And we have only one point where we need to do this configuration. Because for the commons logging and log4j, this is just forwarding. This do not know any configuration. Everything is forwarded. And the SLF4j API do not need any configuration too, because this is just an API. The only real implementation that we now have is the Logback Classic that is used as the underlying logging framework. And this needs to be configured to define where our logging should be stored. So this is a general idea how such a logging facade works and how the different functionalities that a logging facade needs to provide works in general. But so this is not the only solution, SLF4j. As we will see later, there are more logging facades than this one. And to be fair, there is no simple solution. So what I've showed now on this slide works for one specific application where commons logging and log4j is used. So when you have your own application, you really need to have a look at what kind of loggers are used in my application. So what kind of adapters do I need to forward the logging informations to my logging facade? And you need to define what kind of underlying logger do I want to use to, at the end, really provide a configuration and store the logging somehow. But at the end, you can use such facades to really configure complex use cases. And once you know how to use them, you can really collect all the logging from all the different parts and dependencies of your application. And even if there is a logger, I don't know, if a dependency creates their own logger, you can use the SLF4j API to create your own bridge or your own adapter to forward the logging to, in this case, for example, SLF4j. But in general, you will already find an open source solution for loggers that are commonly used. When having a look at the logging facades, so Stefan already showed us some of the logging frameworks that are out there, and some of them are really logging facades because they have a split between an API and an implementation, and they provide this bridging functionality so that you can forward other logging frameworks or messages from other logging frameworks to them. I assume the most commonly used facade is SLF4j, but log4j 2, so the version 2 of log4j, provides the functionality too. And even commons logging has a split between an API and an implementation. maybe for some of you, it's interesting that Java 9 and 10 is mentioned here. And this is based on the new Java System.Logger that was introduced to OpenJDK in version 9. This is based on a JEP. I added the link to the JEP to the slide where you can find all the information about it. And this is a minimalistic logging facade or logging API that has been introduced to the OpenJDK. And this is, first of all, internally used within the OpenJDK whenever a logger is needed. And since it's a facade, you need an implementation or an adapter to use the logging at the end. And the System.Logger here internally uses the Java SPI to get a adapter. And by default, if you do nothing, java.util.Logging is used here. How to use a System.Logger? Here again, we see a kind of hello world. So you can see it's really just system.getLogger. So the system class where you do system.out and system.currentTime in millis. Since Java 9, this has a new function, which is called getLogger. And this returns a logger for you. And now you can use this logger to create log messages. It's not as rich as, for example, SLF4J, because some functionality is missing here, but it has some other good functionalities. For example, the support for suppliers. As you can see in the second log line, here a supplier is used, and Stefan already discussed this, right, when talking about performance, that from time to time, we do not want to concatenate the strings directly, or maybe even create the strings when the log is really used and not filtered out. And the System.Logger from Java provides here the functionality to use supplier to provide the log information that is quite good when talking about performance. So now the big question is, whoa, this is new. So is this the successor of SLF4J? Should I now only use this in all use cases? Actually, I would say no. Because when having a look at the so-called non-goals of the System.Logger API, so the goal is not to provide any logging configuration, but this is what a facade does in general. And next to this, the goal is not to define a general purpose interface for logging. So the most important use case of the System.Logger was to have an internal facade within the OpenJDK to forward the logging that is created in the OpenJDK, not always to java.util.Logging, but maybe directly to another logging framework. But so this means that you should not use it within your big application as a default logger. But what is important is that you think about it, and when having an application that uses Java 9 or Java 9 plus, to check that your logging facade that you are using provides a bridge to the System.Logger, so that everything that is logged by the System.Logger really at the end is corrected or is pushed to your logging facade, so that you get this information within your logger too. If you, on the other hand, just create a small library and not an application, there it might make sense to use a System.Logger to remove dependencies. So if you think about, I don't know, you write something like JUnit, for example. By using the System.Logger, you can easily remove a dependency to, for example, SLF4J or the SLF4J API, because you then just can simply use the System.Logger that is coming with the OpenJDK and provide log messages from your logger. Yeah, this is about how to log Java applications and how to use the different APIs and libraries that are out there to catch all the logs that might be created by your application. And this is already great and works quite good when you have one application. But there is even more. And Stefan and I titled this with Centralized Logging. And this is the next step we want to talk about, because when having a look at application landscapes today, you not normally have just one application. In a real-world scenario, this is not enough, because when having a look at applications today, maybe your application is clustered. Maybe it's behind a load balancer and you have 10 instances of your application. By the use case or by the samples that we've seen so far, each of these application instances would create their own logging in maybe a custom logging file. But maybe you do not have a session and a user is with one request using node 1 and with the other request using node 9. So you do not want to split information from one user in several logging files. Next to this, normally your application is not just one application. Normally it's connected to some kind of infrastructure, like, for example, a database. Or maybe it's running within a Docker container. And maybe you want to synchronize that logging too, so that you not only have the logging of your application, but the logging of your database and your infrastructure, like a Docker container, included into one big log information or log file. And next to this can become quite big, right? And as Stefan mentioned earlier, we normally don't want to delete logging. So what we need is a good way to search and display our logging, because based on the ideas that we just discussed, your logging files will become over time bigger and bigger. And this ends in files that maybe are not that good to handle anymore. So it makes sense to leave the log files behind us and discuss about better ways how we can store our logging. And this is where centralized logging comes into place. And it even gets worse, and there you might understand where the problem is when we talk about microservices, right? Let's assume you are Netflix and you have 300 of services and one user is routed between this 300 of services, and you want to understand what happened for this user. It's nearly impossible if each of the services provides their own log files, right? This would end in endless log files that are based on random services somewhere on the world. So what we need at the end is a way to centralize our logging, to have a place where all log messages, wherever they are coming from, are pushed to or are pulled from the place from some systems. And since the amount of logging will become quite big at such a place, we need a good infrastructure and functionality there to store the logging, index the logging maybe, and then search the logging. And happily, there are tools out there that provide such functionality. This slide shows mostly all tools we've found so far, and there are definitely more. So these are the bigger tools that you can normally use. And on the left, in this orange rectangles, you can see the different logging formats, how a logger, like an application logger, a logger from a database, from a Docker container, and so on, can provide log informations. And what such centralized logging tools normally do is they collect the informations by getting them over, for example, a TCP or an UDP stream, or even maybe HTTPS requests. One example, because we cannot talk about all of them, one example we want to have a deeper look at is the usage of the central logging management tool Quaylog in combination with Gelf. Gelf is a logging format that is supported by several tools, APIs, and loggers. It's a JSON-based format. And this can be used to just forward or send logging information to a central storage, which in this case is Quaylog. So you see different kinds, like an application, a Docker container, or a database here as examples where Gelf log message might come from. And this is what you really see in the right. So for Docker, for example, it's quite easy to configure Docker to use Gelf as a logger appender. This is can be done by Docker by default. Docker directly supports it, and then send the log information to a centralized logging. Mostly all Java logging frameworks that you know support Delph 2. You will find libraries that provide appenders for the different frameworks to send this Delph information to a central point, like in this case, Quaylog. And Quaylog is a service. It's a backend service, but it has a nice front end that you can use to, for example, show your log information, to search your log information based on time, based on different tags, based on maybe logger names, or maybe the source where the logs are coming from. Here, what we see here is the internal information of a log, where we see, first of all, a timestamp and a message. But below, we see a lot of metadata, like an actor, a namespace, an object. And this is what Stefan earlier told us about how to send metadata within loggers by using things like MDC or markers or tags. Now this becomes really handy, because when we have that much logging information, we can now have a deeper look. Okay, what user was it? Maybe the user is a tag. What system was it? And so on. And we can really filter our logging and have a look at use cases by defining custom filters, even if the use cases contains several systems where log files or log informations are coming from. So this was just a short overview about centralized log management and what you can do there. We are quite happy with that solution. So we did this already in several projects. But since we are running out of time, we can't go deeper here. One last thing that we want to show is some ideas where the whole logging topic might go into future. I think there were several ideas, but we just picked two. One is tracing. So when I talk about the future, some of you might say, hey, tracing is already there. Yeah, totally fine with it. And tracing is there, and there are quite good tracing libraries and even tools to centralize tracing and to visualize trace routes, for example. And so tracing is something where you can follow a request over several services within, for example, a microservice architecture. And this is done by internally adding metadata to the HTTP headers of the requests and response. But this can easily combined with logging, or the tracing information can be added as metadata, as MDC metadata, or as tags or markers to the logging information, so that we even can combine the tracing information with the logging and nicely see all the logging information for one trace, for example, to see the logging just for one user interaction perfectly filtered. Another interesting point is where a lot of companies currently do research is using artificial intelligence with log systems. Some call it like log intelligence. And this will be used to get a better feedback. So you might think about that the logging tool understands what log message happens when an error happens. And maybe based on this, they can detect errors automatically, or even better, detect that, oh, there will be an error happen within the next 5 minutes based on what I'm currently seeing in the logs. And you can be alarmed even before an error happens. That would be perfect. Next to this, it can be used to understand the workflows and behavior of your users. Maybe you have users that does always exactly the same 3 steps within your system. And maybe you can then automate these steps and provide a better user experience to your user based on what you learned out of the log files, or what the artificial intelligence tells you based on your log files. But these are just some ideas where currently a lot of research is happening. Yeah, that's about what we have today. I think one of the most important outcomes of this talk is that you should, if you do not do it today, use a logging facade. If you have a bigger system, definitely use a centralized log messaging tool. But if you have, for example, just one application, a log facade is already a great start. Stay safe and healthy, and we hope you liked the talk. If you have any questions, I think we still have some minutes, so Stefan and I are here to answer your questions, or comment or talk with you about the talk if you have any comments. First of all, thanks for listening, and we hope you learned a little bit new about logging in Java. Thank you.